Okay, so I will explain the system that I have here and that I have in the studio, which is pretty similar to this one, that it's on more devices, and I didn't bring all of them because it would be too complicated. Even this was really, really complicated. So we have two EQs and one compressor here. We have a Firewire digital audio card. We have an analog to digital converter and digital to analog converter, and we have monitor controller with integrated DA converter. So this is just a remote. This is just a remote for a Crane Sound Evo set, which is actually all the electronics are in here. The system that I use is based on the principle that I will use digital EQ for cutting and for cleaning up audio, and only after that I will insert analog outboard into the workstation, and I will usually boost with analog EQs. I will rarely cut. I will do all my cutting and cleaning up in digital domain because I think that it's more precise and you can automate it, for example, and you have several options which are not available in analog world, like linear phase filters and stuff like that. So let's see if this works now. Okay. So everything works now. So we have a really, really cool disc track. So it's not too electronic and it's not too rock, or it's not rock at all. Anyway, you can hear that I have the original file, and then I have additional copy, and then I have additional copy of the file, and I will make another one. So I have 4 copies of the same file running in parallel. Why do I need that? Because if I want to be correct, I will have to compare the original file to the mastered file. So first track goes to stereo output, which is connected to the monitor controller through ASEVU connection, meaning that this sound card is Firewire to digital. It doesn't have any analog converters on it. It's just ASEVU in-out, SPDIF in-out, and optical in-out. So ASEVU 1 stereo out from Logic goes to ASEVU input on the monitor controller, actually here, and it has a built-in DA converter. So the converter is actually here, and I'm feeding it digital signal. The second channel goes to output 3.4, which is connected to the second digital input on the monitor controller. So I can listen to the same mix here. So if we listen to it, it's exactly the same. Does anyone hear the difference? There shouldn't be any. So the point of that is that when I will be processing, I will be constantly comparing my processed master to the original master. So therefore, I will not lose perspective on my process, because if you don't do that, you don't know what your processes are like. You may be shocked when you will compare your master to the original, how better the original sounds. Because sometimes when you are mastering, you have to work hard not to destroy the audio, to do as little as possible, and sometimes you have to do as much as possible. So the third channel will be a sidechain output track. This track will go to a sidechain input of this compressor. In this setup here, it's not connected because it's not possible. But this means that I will have a digital EQ, sometimes I put analog, inserted in the sidechain input of the compressor, running in parallel. So during mastering, I will be changing parameters on the sidechain input of the compressor. A lot of you probably don't know what a sidechain input of a compressor is, but I really don't have time to explain it. This is the signal to which compressor reacts. So I am manipulating the signal to which compressor reacts, so it's processing the audio that it's passing through in a different way. And you can see that I high-passed the audio above, approximately at 40 Hertz, that I have a slight cut at 100 something, then I have a slight cut at 200 something. So by manipulation of a sidechain signal, I can get specific effects from a compressor which are otherwise unavailable. And the third track is a parallel. And there is nothing inserted on this parallel, but I could insert an external compressor, I can insert an external saturator, or I can insert a plugin to it. So what will happen if I add this signal to the original? It will be just louder. If I flip the phase, absolute total silence, that means that those signals are completely aligned in phase. So whatever process I will add to this parallel, if the plugin has latency compensation, will still be completely in phase, and I can freely mix it to the original signal. For example, but I will do it later, it's not important right now. So the first thing that I have in chain is linear phase, in this case minimum phase, high pass filter with a little bit of resonance. So what I'm doing with that is removing. It has a huge latency because it's set to maximum resolution and it's working in linear phase mode. And if you are looking into a processor mode somewhere there, you can see that it's taking out almost one processor just for high-pass filtering duties. So it's extremely CPU hungry and it has extreme latency. And because it's working in upsampling mode, it's actually working at 176.4 kilohertz. So it's taking even more DSP resources.
So have you ever made any A/B comparison between this EQ and the Logic's?
No, I really didn't. I think it's a waste of time. I think Logic's EQ works really good. For mixing high pass, low pass, it's extremely good.
I mean this
for
linear fuse.
No,
linear phase.
I use this one because I don't know, I kind of like its interface, and I actually like its sound, and I like that it has MS capability, which comes handy sometimes. Yeah, anyway, so if I have a filter like that, I can filter out all the frequencies below the fundamental note of the song. So how can you hear precisely where is the cutoff point for the high pass?
Turn the resonance up.
Turn the resonance up, this is one thing. Another thing is you can use low pass and you can focus only on the sub-range. This is just a help, a little help, so you can more clearly hear what the high pass is actually doing to the signal. It's difficult to hear what is happening in the low end if you have a lot of information in the mid and in the high range, especially if you don't have a full range speakers. So if we are going from here, I can boost the resonance. Really difficult. I mean, I don't hear it here, but on my system I can clearly hear the difference. So I would find a frequency which will give the kick and the bass the most power and the best relationship between them. You try not to destroy the relationship between the kick and the bass, and usually in good mixes kick is below bass frequency-wise. So you will be able to, if the mix doesn't have enough kick, you will be able to boost the kick slightly just with the resonance and the high pass filter. So usually I will listen carefully and try to find the right frequency, and then I will reduce the Q. So if I bypass it, you can hear a slight change in energy in the bass. So the stuff that I cut it here, I invested here in the cutoff point. So I saved energy below 25 Hertz, which is irrelevant, and invested that energy above 25 Hertz, where is my fundamental note of the song. It may be higher. In this song, case was something like this. And this is really subjective. You may find something else if you listen to it. So everyone will master in its own way with his own perspective. But I read like several tutorials that you should cut everything below 30. I read you should cut everything below 60. This is total bullshit. You have to listen where you are cutting, because maybe this song will be better without the actual filter. But we can hear, even if I put it really loud, that the bass is more punchy, more precise, and has more concrete sound. But this is not necessarily good for a song. For this song, it was a good example. And after that, I will go to full range, and I will listen again what happens to the harmonics, bass harmonics, when I use the high pass filter.